So right now what we're looking at is R squared, the coefficient of determinations. And the equation for coefficient of determination is SSR divided by SST. That's the equation for R squared. And what R squared does is that it explains the proportion of total variation in the dependent variable, which is your Y, that is explained by the independent variable, which is your X. Okay, so this is what R squared tells you. And what you need to understand about R squared is that when we look at R squared, you need to understand the concept of total variations. So when we run our regressions, there are two types of variations. So we have SSR and SSE. Okay, and those two types of variation add up to your SST. Okay, so we have SST equals to SSR plus SSE. What SST does is that it looks at the total variations. So SST is the distance between your blue dots. If you look at it from the diagram, SST is the total variation. That total variation is the distance between your blue dot and your red line. So red line is your Y bar. Y bar is your average value. That's your expected value. Right? So what you expect to get, that's your expected value. What you expected to get is your average. So this is the average. And then your blue dot is your actual observed value. So this is your actual observed value. And the distance between the actual and your expected is what we call SST. That's your total variation. And then SST is broken into two parts, SSR and SSE. Right? So SSR is the distance between your predicted. So predicted is as in your blue line. So is your line of best fit. So your predicted is your Y hat. Okay, so from the regressions, we have our predicted value, and the distance between your predicted value and your expected value is your SSR. So the gap between your blue line and your red line, your expected and your predicted, that gap there is your SSR. That's your what we call the explained variations. So these are the variations that are explained by this model. And what we also have is your SSE. SSE is your unexplained. Okay, so SSE is the distance between your actual and your predicted. So SSE is what is unexplained by this model. So your SSE is your unexplained, and your SSR is your explained. Right, so SSE is the distance between your blue dots and your predicted value, your blue line, and the SSR is the distance between the blue line, your predicted value, Y hat, and the Y bar, which is your expected value. So once we understand the diagram, once we understand what is explained and what is unexplained in the model, then when we look at the equation for R squared, we know that R squared equals SSR divided by SST. That makes sense because SSR is the explained portion and SST is your total variation, right? So SSR, explained variation divided by total variation, is basically your R squared. And then what you need to know is that R squared is always positive, right? Because R squared, when you take a square of any number, it will always be a positive value, right? So that's why R squared will always be between 0 and 1. Right, because it can't never be negative. And what we have is that when your R squared is 1, that means we have perfect linear relationship. And then when R squared equals to 0, we have no linear relationship.